Hello students, in this lecture we will use mean value theorem to drive some important inequalities. So let's write first inequality. Use mean value theorem to prove 1 plus x is less than equal to e is for x is less than equal to 1 plus x is for x greater than equal to 0. Two possibilities will arise. One is x is equal to 0 and x is greater than 0. That is x belongs from e to x then arbitrary. Let's do the first case when x equals 0, put x equals 0 in the equality, given inequality. 1 plus 0 is equal to e is power 0, is less, 1 plus 0 less than equal to e power 0 is less than equal to 1 plus 0 equal 0. So this is 1 plus 0 1 and this is less than equal to 1. This equality holds for x equal to 0. 1 is equal to 1 is equal to 1. Equality holds. Therefore, for x is equal to 1, 0, 1 plus x is equal to e power x is equal to e power 1 plus e power x into e power x. When x is greater than 0, consider the function. Consider the function which we have to prove this function. Consider this function that f t is equal to this is for t, and derivative this f t is equal to is for t. So this function is f t is continuous in the continuous for all values x, therefore continuous in the interval 0 to x. Because we have to go with one itself, therefore we have taken the interval 0 to x. Otherwise, these two for 0 to for all values x, and we asked to show it for 0 to infinity, so we have to assume that 0 to x. And this function is differentiable. When you differentiated f t is to t, we got this for t, and this also considered for all values of x. Therefore, this function is differentiable in the open interval 0 to x. So ft satisfies both the condition of Lagrange theorem in the interval 0 to x. Therefore, there exists at least one real number c belonging to open interval 0 to x, such that fsc is equal to fx minus f0 from x minus 0. Now substitute the function here in this inequality, equality. E power c is equal to e power x minus 0 from x minus 0. E power 0 is equal to 1, so e power c is equal to e power x minus 1 upon x. Now from this we know that this c is lying in the interval open interval 0 to x implies 0 less than c. Now we find the value of EC. Where will this EC lie? This will be general procedure for every problem. So if this is lying between this, therefore E is a positive number. The positive number E is for 0 is less than E for C is less than E for x. Because value of C is equal to 2.73. 2 0 is equal to 1. 2 plus C is equal to 2 plus C, whatever number it will be greater than this, and 2 to H, because X is greater than C, that will be this will be greater than this. Now for first and second, substitute the value of E equals C here. This will be 1 is less than equal to 1 is less than equal to E equals C, E equals X minus 1 upon X. Now X is greater than, we know we have to in the second case when X is greater than, or X is greater than 0. So if you multiply the equality by x, inequality positive number, equality is the same. So whatever the x is equality, x is less than equal x minus 1 is less than x into equal x. Now adding to one further equality, equality with this. Equality with this without. So to 1 plus x is less than equal x is less than 1 plus x is equal x. Combining a and b, we got 1 plus x is less than equal to x is less than equal to 1 plus x is equal x for all x is equal to 0 volts. Second problem. Prove the following by examining the sign of derivative of an approximate function. So, approximate function x is less than equal to minus log of 1 minus x is less than x into 1 minus x is minus 1 for 0 less than x is less than 1. X from open to 0 to open to 0. So for this You have to remember this step, first step only. So let's consider ft. Ft is equal to t plus log of 1 minus t. How? T plus log minus t, when you put x equal to 0, so you get log of 1 minus 0 minus 1. So this is equal to, derivative of this will be equal to, and gt is equal to, ft is this, and gt is equal to, uh, gt is minus log of 1 minus t, minus log of 1 minus t, and t, t minus t into 1 minus t is equal to minus 1 for all t comes to 0, where x is any real number belong to open interval 0 to 1. So derivative of ft, we have assumed these two functions. So ft derivative is equal to 1 minus 1 upon 2, and then this will be equal to 1 minus 1 to cancel 1 upon 1 minus t, and derivative this will equal to product first function derivative second minus second function derivative first derivative. Now simply after simplification we got LCM, LCM here we got is equal to f plus t together minus t minus 1, and this is equal to is equal to minus 1 upon t minus 1 minus t equals to. Now these two both the functions ft and gt are strictly decreasing function in this interval, because strictly decreasing function in this interval, you can check it also there. So that means this is equal to f, and this interval 0 to x open closing interval. So this will take if it decreasing, then if x is 0 is less than x, because x is like 1 0 to 1 less than, then fx will be decreasing, definition decreasing, fx is less than f0 and gx is less than g0. Substitute the value, fx is less than 0, gx is less than 0. After substituting their value, we got into x is less than log of, x is less than minus log of, minus log of, taken to right hand side, minus log of x minus t, and the minus log of this is less than x minus 1 plus x equal minus 1. Now combining these two, a less than b, b less than c, therefore a less than b less than c holds true. So here, how to remember this, how to find this? This is equal to t plus this, and gt is equal to this minus this, with this minus this, this minus this minus this, take it to the left hand side, and this take it to this side. So at the end, just step out of this. Next is use Lagrange mean value theorem to prove that x is less than sin inverse x is less than x upon under root of 1 minus x square for x belongs to the control 0 to 1. When x belongs to 0 to 1, so 0 to 1, then x is a positive real number, and sin inverse x, that is sin inverse x, what will happen? Sin inverse x will be, this is, what is the limit function? What the number? When it's from minus 1 to 1, and therefore this also belongs to this, so this is a well-defined function. This is 0 to 1, 4.0. So therefore, if we take x, any arbitrary number less than 1 and greater than 0, so this function is sin inverse x is continuous in this interval 0 to x of closed interval, and differential in the open interval 0 to x, differentiated, this will be 1 upon root of 1 minus x square. This is defined in this interval because x is equal to less than 1. Therefore, fx satisfies both the conditions of the Lagrange mean theorem. Therefore, there exists a as this one universe q, q such that 1 is less than q less than 1, q less than q less than 1, such that fx is equal to fx equal to f0 plus x into f dash, second method other form, f of a plus x is equal to f of a plus h into f of a plus x, h plus h. Using this, it will be 0. So now substituting the value here, let's see, f0 and f dash x dash. So we got sine inverse x is equal to f sine inverse is equal to 0. So x are known under root of 1 minus theta square x square. Now we know, since we know that 1 is less than theta less, now we'll find the value of this. Compare two sides. So 1 is 0 less than x theta less than 1, and 0 less than x less than 1. So they, if you multiply them, they multiply this by x, we got x greater than 0. So equality means the same, 0 less than theta x less than 1. The square, if it is less than, the square will be less. Equality holds for the square. So 0 is less than theta. So we converted to this form. By using these steps, we are converted this, with which this will be less. So 0 less than theta square, x square less than x square. Now multiplying is equal to minus, because minus is here, multiplying is equal to minus, equality reverses. We will greater than minus theta square times theta square x square then minus x. Now 1 is here. Adding the 1 to equality, equality in the same. 1 is greater than 1 minus theta square x square is greater than 1 minus x. Now please, taking the positive square root of this, equality means this, equality means result, and we are equality equality result. Root of 1 minus x square is less than root of 1 minus theta square is less than 1. Now divide, now if there is, if there the reverse will be the positive numbers. They are positive numbers. The reverse, if you reverse the equality, equality will be reverse. Reverse the positive number, the reverse, so 1 1 minus x square is greater than 1 from root of 1 minus theta square is equal to 1. Multiply inequality by x, x is greater than 0, equality remain the same. So this implies substitute the value of x upon this, and this